In this video, we're going to learn about a special type of right triangle, and it's called an isosceles right triangle. And the reason why is because there's a special relationship between any sides of an isosceles right triangle. So first of all, if you think about an isosceles right triangle, you have to have both isosceles and a 90-degree angle. So isosceles means two congruent sides or two congruent base angles. So that means these angles would have to be 45 and 45 so that all three angles still add up to 180. Subtract 90 from it, divide it by 2, you get 45 and 45. So sometimes we'll refer to these as 45, 45, 90-degree triangles, which basically means isosceles because it has two congruent angles and a right triangle. So what happens in an isosceles right triangle, since these two sides are always congruent, the hypotenuse will always be radical 2 times the legs. And the reason for that is if we just look at Pythagorean theorem for a second, so if I say I have this right triangle, that's isosceles, I call this x and x, and I label this c. If I go to use Pythagorean theorem to solve for c, it'll be x squared plus x squared equals c squared. Combine like terms, you get 2x squared equals c squared. And then solve for c, so square root both sides. What ends up happening is you get the square root of 2 times x is equal to c. So see how that's exactly what I have over here, x times the square root of 2, or the square root of 2 times x. So that's where it comes from. So basically what that means is you end up with these two formulas, that the hypotenuse will always be radical 2 times the leg. So if you start at one of the legs, you multiply that by radical 2, and that'll always give you the hypotenuse. Doesn't matter which leg you start at because they're the same. So this is only going to work in an isosceles right triangle because the two legs are congruent. So this is the same thing as saying that the ratio of the legs to the hypotenuse is 1 to 1 to radical 2. So let's look at how we can use this. So for these, it says exact answers only. So that just means we're going to leave it in terms of square roots and not actually get a decimal. And when you look at this picture, if you're trying to find x and y, well, the first thing you could do is you could use sine, cosine, or tangent to solve for it. Set up your trig ratio, but then again, that's going to give you decimals when you put them into your calculator. We want exact answers. So that means we're going to use the shortcut. We're going to use this 45, 45, 90 triangle. I know that all of these triangles pictured here are 45, 45, 90, because if this is 90 degrees and this angle is 45, this one has to be 45 so that all of the angles add to 180. So that means I know x and y are equal. And that's the same thing for all of these triangles. Because it's a right triangle with a 45-degree angle, that means both angles are 45 and all sides, both legs are congruent. So that means I can use my 45, 45, 90 shortcut and get exact answers by using the fact that the hypotenuse is going to be radical 2 times the leg. So that's what I'm going to be using here. So let's go ahead and write that out. So hypotenuse equals radical 2 times the leg. So the hypotenuse is 10, and the leg, so these are equal. So to get to the hypotenuse, it's times radical 2. So 10 times radical 2, or 10 equals radical 2 times the leg. We want to find the leg. So divide both sides by radical 2, and you end up with 10 over radical 2 equals the leg. So this would be an acceptable answer. The other thing that could happen here is if this is a multiple choice question, you might have to rationalize. So this counts as an answer, but rationalizing means we don't want radicals in the denominator. So that just means what you do is you multiply the top and bottom by whatever that radical is. This is like multiplying by 1. It's just in a different format. So it's not changing the expression because you're multiplying by 1, but it's making it so that you don't have a radical in the denominator. So this would end up being 10 root 2. And then on the bottom, when you do root 2 times root 2, that's going to be square root of 4. Square root of 4 ends up being 2, or the roots cancel each other out. Then this would be 10 divided by 2, gives you 5 root 2. So an equivalent form of this is 5 root 2. So that means for y, it's going to be the exact same thing because these are the congruent legs of the isosceles right triangle. So really either form is acceptable. It's just if it's multiple choice, you're going to see only one answer. So let's go ahead and try another one. So again, we have our 45, 45, 90 triangle. So we know that the hypotenuse is going to be the square root of 2 times the leg. So that means starting with the leg to get to the hypotenuse, it's times radical 2. So essentially what you're doing is you're going backwards. So 14 divided by square root of 2 is going to give me x. If I plug into the formula, same idea. We're trying to find L. So divide both sides by square root of 2. So that means 14 over root 2 is the length of the leg. So 14 over root 2. Or we can rationalize this. So this would be one answer. Or 14 over root 2, meaning now to rationalize, multiply top and bottom by root 2 to get rid of that root on the bottom. So we have 14 root 2 over 2. So it ends up being 7 root 2. So either or, and again, y is going to be the same thing because it's the congruent leg in the isosceles triangle. So keep moving here. We have, again, we have the hypotenuse. Sometimes you're going to be asked to find, instead of finding the legs, you're going to be asked to find the hypotenuse given one of the legs. So you just use the same formula. It'll just work a little bit different, that you could just take the leg and multiply it by radical 2, and that'll give you the hypotenuse. Otherwise, if you have the hypotenuse, we're going backwards, so we're dividing by root 2. So it's the hypotenuse times square root of 2, or hypotenuse equals square root of 2 times the leg. So we go ahead and we plug in the hypotenuse equals root 2 times the leg. So we're going to divide both sides by root 2, just like in my drawing here, going backwards, dividing both sides by root 2. So those are gone. Now when we divide this, watch what happens. Because it's a square root divided by a square root, you can actually divide the numbers underneath. So what's going to happen is it's going to be 8, and then 8 divided by 2 is the square root of 4. And that's because they're both radicals, so you can divide them. Same thing with multiplying. Just be careful, addition and subtraction, you have to have the same number under the radical to be able to do operations with it. So a multiplication and division, though, you can just go ahead and actually do the operation. So I divided, and then this becomes 8 times 2. So that really means that the leg is 16 here. So for both of those, it's just going to be 16. And then for the last example here, again, to get from either one of the legs to the hypotenuse, it's times root 2. So if I'm going backwards, really what I'm doing is 11 divided by root 2, and that's going to give me x. Or you can write your formula, square root of 2 times the leg. So plug in 11, square root 2 times the leg, divide both sides by square root of 2. So you get the leg equals 11 over square root of 2. So that's an acceptable answer, but if we want to rationalize that, we would have 11 square root 2 over square root 2, and then multiply top and bottom by the square root of 2. So we get 11 square root of 2 over 2, and we're just going to leave that like that because I'm not going to, I guess you could write it as 5.5 square root 2, but I would just go ahead and leave it as a fraction. So 11, so you could write 11 over 2 square root 2, or you could leave it how I have it over there, 11 square root of 2 over 2. Lots of different ways to write it. They're all equivalent. So in the end, all the same answers. Just be careful that in a multiple choice question, it might be written differently. But in that case, you could always put these in your calculator and make sure that the decimals match. That would be another option. So there is a shortcut. Remember, you can use SOHCAHTOA to kind of check your work. If it doesn't say that you have to give an exact answer, you could use SOHCAHTOA. I could do sine of 45 equals x over 11, opposite over hypotenuse, and solve and get a decimal that's equivalent to this root. But if it does say you need an exact answer, that's where these are really going to come into play. Plus, they're quicker instead of setting up the formula for SOHCAHTOA. So get your key ideas written down. and do the check your understanding problems, and we will talk about those in class tomorrow.